Early in this century, the physicist Robert Goddard proposed that rocket would someday be sent to the moon. He met strong opposition from people who thought that such a feat was impossible. They thought that a rocket could not work unless it had air to push against. This activity constructs a balloon rocket system that will travel across the room. Also, we're investigating the causes of observed effects and action-reaction relationship.
So the materials needed before we start the experiment is a string, a balloon, a straw, a tape, and a clip.
Now let's start the experiment.
As we constructed and tested the balloon rockets, we observed that the rocket moved when the air escaped from the inflated balloon. This movement was a result of a stretched balloon collapsing, forcing air out, and the air in turn pushing back on the balloon.
The inflated balloon moves when the air escapes because the force escaping the balloons pushes it out to move forward to the direction it's heading. In simple words, the air rushing out of the balloon is the action that squeezes out the balloon movement into the opposite direction, which is the reaction to the action. The rocket action would still occur even without the surrounding air, because it is the air that is being pushed out of the balloon that enables it to move and not the surrounding air. In fact, we think that the air that surrounds the environment of the balloon is the one that hinders its acceleration. Newton's third law of motion, which says for every action there has an equal and opposite reaction. Based on the data, the air that blows up inside the balloon, which is going to be a force, the air escaping the balloon pushes out in every direction, and the balloon is to move forward in every direction. This happens because the gas rushing out of the balloon is the action, and the movement of the balloon in the opposite direction is the reaction. So, forcing the air out of this way will allow the balloon to go to the opposite way to have an opposite and equal reaction. This hands-on activity provides a practical understanding of action-reaction relationships, which illustrating how forces result in motion according to the Newton's laws.